In this video, we're going to talk a little bit about multi-particle systems and how those relate to the momentum principle. So here I have a system of 3 particles, each with its own velocity. And so when I bound that system, when I say these are the 3 things that I'm going to consider as part of my system, I'm defining what the total momentum is for that system. It's simply the sum of each of the individual momenta. So when I start to write down what the momentum principle is, I'm going to take the time derivative of the total momentum. And as a result, I'm going to individually take the derivatives of each of the momenta of each particle and add them up. That's how we distribute these derivatives. So for each of these particles, there are interactions that occur. And so particle 1 will interact with particle 2 and 3, but also interact with what we would call the surroundings, the things that are outside of the system. So it's really important to define your system and to define the surroundings, because you need to know what is interacting with what. So as we go through and we add up all of these, we're going to find that the interactions that particle 1 has with particle 2 cancel the interactions that particle 2 have with particle 1. So as we adding each of these together, what we're going to find is the total sum is really just the net interaction that the system has with its surroundings. This is the external force to the system times the amount of time that's elapsed while you're looking at the system. And so in this case, the total momentum change of the system is given by the net external force.